Course 2, Study Guide number 4, page 1. 108 divided by 8 is an improper fraction. So if I'm going to reduce it, the first thing I'm going to do is divide 8 into 108. You always divide the denominator into the numerator. 8 will go into 10 one time. Subtract, you get 2. 8 will not go in, well, I've got to bring down my 8, and so then 8 will go into 28 3 times. 8 times 3 is 24. Because I'm doing this as I started with a fraction, an improper fraction, I'm going to write it as a mixed number. So when I get my remainder of 4, instead of going on and dividing as a decimal, which would technically be okay, I'm going to go ahead and write my remainder as 4, excuse me, divided by the divisor, which is 8. Now, because 4/8 is not in lowest terms, I'm going to divide by 4 over 4. You have to divide by a form of 1, and you get 13 1/2. Don't forget to bring your 13 over. 5 4/3, I'm going to go over here and do that one. I'm first going to take the 4/3 and do the same thing I did with the 108 over 8. I'm going to divide 3 into 4, and it goes one time with 1 left over, so remainder over the divisor. So now I've got the 5 4/3. The 4/3 became 1 1/3, so I'm going to add the 5 back to it, and I have 6 1/3. Now 120 over 150 is a proper fraction, so all I've got to do is divide by forms of 1 to reduce it. I see a real obvious division, dividing by 10 over 10, and I can do that by just canceling my zeros out. So I now have 12 over 15. I can again divide by 3 over 3, and I get 4 over 5. There's nothing else that will go into 4 and 5 except 1, so it's in lowest terms. Prime factorization is just a fancy name for factor tree. Several ways to do it. I'm going to do it, I think I'll call it the birthday cake method. So I'm going to divide 150. I'm looking for prime numbers. Well, remember your prime numbers are 2, 3, 5, 7, 11. Shouldn't go any higher than that, ... So we'll start with 2. You could start with 3. You could start with 5. But 2, to me, I just always start with the smallest one. 2 goes into 15 7 times. And 2 goes into 10 5 times. Now, at that point, 2 will no longer go into it. If I go up the list, I'll see if 3 will, and 7 plus 5 is 12, so 3 will go 25 times. 3 will not go into 25, so let's go up to the 5, and 5 goes 5 times. When my top number is a prime number, then I'm through. So the prime factorization of 150 is, I'm going to put it right here by my 150, I had a 2 times a 3. Now you can write it 5 squared, or you can just write it 5 times 5. But be sure and put your dots, because prime factorization is multiplication of prime numbers. 624 books were packed in 26 boxes. If each box contained the same number of books, how many books were packed in each box? So I'm taking 624 books, and I'm splitting it up into 26 boxes. So we need to know how many books are in each one. 26 won't go into 6, but it goes into 62 2 times. 2 times 26 is 52. Subtract, I get 10. Bring down my 4. And 26 will go in 104 exactly 4 times. So there are 24 books in each box of the 26 boxes. Number 4. Jan went to the ball game with $20 and returned with $8.20. How much money did she spend at the ball game? So she started with 20, and she was left with $8.20. So whatever she spent was whatever's, if you take this from this, that's the amount that she would have spent. So let's just flip that and take the $8.20 from the 20. Have to do some borrowing here. Let me go all the way over to the 2 and borrow 1. That makes this a 10. Borrow from the 10, make it a 9. Make this one a 10. So now 2 from 10 is 8. 8 from 9 is 1. And 1 minus 0 is 1. So Jan spent $11.80 at the ball game. You can check it by adding the $11.80 and the $8.20 back together. 3/8 of the 64 marbles in the bag were blue. How many were blue? Well, we can write 3/8 as a fraction. Of means times, and then the whole group is the 64 marbles. And I'm going to go ahead and put a 1 under that. Now, you can multiply and divide, but I find it easier to cancel. 8 goes into 8 one time. 8 goes into 64 8 times. 3 times 8 is 24. 1 times 1 is 1. So there were 24, and these were the blue marbles. Okay, how many were not blue? Well, if you've got 64 marbles to start with, and 24 of them are blue, then when you subtract, 40 of them are not blue. If one marble is drawn from the bag, what is the probability of drawing a blue marble? Probability of a blue is the total number on the bottom of marbles in the bag, and the top number is what you would have to be successful, which in this case is a blue. So we found there were 24 blue, and there were 64 marbles in the bag. So 24 over 64, 24 out of the 64 are blue. Let's reduce that. I can divide by 2, I can divide by 4. The biggest number is 8, and I get 3 over 8. Number 6, the Roman Empire lasted from the year 800 to the year 1806. How many years did the Roman Empire last? Well, let's take the latest date, which is the 1806, and subtract from it the 800. And so we've got 0 from 6 is 6, 0 from 0 is 0, 8 from 8 is 0, and then 1 minus 0 is 1. So the Roman Empire lasted 1,006 years. Number 7, simplify 8 minus 2 2/3. Write your answer as a simplified mixed number. I'm going to go over here and write it as 8 minus 2 2/3. Well, I can't take 2/3 from anything, from 0, if I don't have one that's cut up that I can take into thirds that I can take 2/3 from. So we're going to take one of our numbers, and we're going to cut it up into 3 pieces, which would make it 3/3. I could cut it up into 5/5, I could cut it at 8/8, but I want to cut it up into whatever my denominator is here. Now we just subtract. 2/3 from 3/3 is 1/3, and 2 from 7 is 5. Number 8, simplify 4 3/5 plus 2 4/5. Well, we already have common denominators, so all we've got to do is add, and we get 6 7/5. Well, let's take the 7/5. I'm going to go over here and divide the 5 into 7 because it's improper, and get 1 2/5, and then put it back down here with the 6, and I'll have 7 2/5. And then the last one is subtracting with common denominators. I'm going to do it over here. I've got 5 1/3 minus 2 2/3. Well, if you only have 1/3, you can't take 2/3 away from it. So let's take one of our numbers, one of our 5, and cut it up into 3/3. So we'll put it with our 1/3. So we're actually going to have a 1/3 and then some more thirds. So I have 4 4/3 minus our 2 2/3, which will leave me 2, and 4 minus 2 is 2/3. And that's in lowest terms.